Hey guys, here we are with chapter 8. Alright, and what is the Pythagorean theorem and when do you use it? Alright, the Pythagorean theorem is a squared plus b squared equals c squared. These are both the legs and this is the hypotenuse. Alright, you use it to find a missing side measure. Alright, so let's use it. Here, we have two sides, and we're missing one. So this would be an A, this would be a B, right? They're both the legs. And this would be our hypotenuse. So, I would say 8 squared plus x squared equals 17 squared. Alright, well 8 squared is 64, plus x squared equals 289, minus 64, minus 64, x squared equals 225. I would take the square root and take the square root, and I would get 15 for that side measure. All right, right here, it says solve for x, leave an exact form. That means leave it as a radical, you guys. If it's not a perfect square, then leave it as a radical. So this would be 10 squared plus 11 squared equals x squared. Well, 10 squared is 100, plus 11 squared is 121, equals x squared. Oh, excuse me. Excuse me, that would be 221 equals x squared. We would take the square root to get x alone, and you would leave your answer as rad 221. Leave an exact form. That's what that means, all right? Because if we give a decimal, remember that's an approximation because that decimal goes on forever. Okay, so number 14, determine whether the three sides create a triangle. If so, classify the triangle as acute, right, or obtuse. Well, is this a triangle? Yes, it is, because 8 plus 10 is 18, and 18 is greater than 12. So congratulations, it's a triangle. Now we need to classify that. If you guys remember how to classify that, we take the two legs, so 8 squared plus 10 squared, and we want to see what it is compared to 12 squared. Well, this is 64, this was 100, and this is 144. All right, well, 164, if the sum of the legs squared is greater, like this is, then it's going to be an acute triangle. Okay, if the hypotenuse is bigger once you square it than the sum of the legs, then it's an obtuse. And if they're equal, then it's a right triangle. So, let's see again, is this a triangle? All right, 21 is greater than 15, so yes, it is a triangle. Sorry, the lights just turned off in here. So yes, it is a triangle. Now let's classify it. I'm going to just draw a squiggly to separate the two problems. 9 squared plus 12 squared, and let's see what it is compared to 15 squared. Well, this is 81 plus 144, and this is 225. All right, well, when you add these together, it's 225 as well, which means this would be a right triangle because they're equal. And now, let's classify these. Well, these add up to 66, so yes, that is greater than 39. Congratulations, that's a triangle. Now let's see what type. 31 squared plus 35 squared, and compared to 39 squared. Right, 961 plus 1225, and that would be 1521. When we add those up, it's 2,186, and that is going to be greater than 1521. So again, we have another acute triangle. Okay, let's move on to question 15. Okay, it says a 20-foot ladder, this is going to be 20 feet, is leaned up against a house, okay? So let's just say that house. is right there. If the base of the ladder is 9 feet away from the house, how high up the house does that ladder reach? So how high? What is the distance from here to here? Well, we just drew a right triangle, all right, and we know two sides, so we're going to use the Pythagorean Theorem again. That's going to be 9 squared plus x squared equals 20 squared. 9 is one of our legs, and x, the other one, is one of our legs as well. Remember, the legs make up the right angle. Okay, so I squared those two numbers, and now I'm going to subtract 81. I'm going to get x squared equals 319, and then I need to take the square root and the square root. I will get 17.86. That's approximately how far up it goes. Okay, so now, one second. I'm going to stop right here. Actually, no, I'm not. Wait. Okay, I'll just keep going. Okay, so now we're moving on. Here's another right triangle, and this time there's a 45-degree angle. And here's a 45. That means you're going to start using your special right triangles. So this is going to be n, this is going to be n, and this is going to be n rad 2. Well, they want me to solve. I need to solve for n so I can figure out what in the heck x and y are. So let's just call it x. I'm going to do 10 equals n rad 2. I need to get n alone, so I'm going to divide by rad 2 and divide by rad 2. I will have n equals 10 over rad 2, which I am not allowed to have. I cannot have a radical on the bottom. So I need to multiply both the top and the bottom by rad 2. All right, that's going to become 10 rad 2 over 2. Rad 2 times rad 2 is rad 4. The square root of 4 is 2. Now I can simplify. 10 divided by 2 equals 5. So I now know that n equals 5 rad 2. Well, it's the same value for x and y, so I now know 5 rad 2 is my answer for both of those. Okay, now let's look at 17. Same type of thing. This is n, and this is n rad 2. Well, lucky for us, we know the n this time. So I know that n equals 8. And then I know for my y equals n. And if n equals 8, then y equals 8. So y equals 8. And then if I'm looking at my x, I know that x equals n rad 2. I know that n is equal to 8, so I'm going to have x equals 8 rad 2. Okay, and now we're moving on to a 30, 60, 90 triangle. So if that's 60, then this is 30. Across from 30 is n, across from 60 is n rad 3, and across from 90 is 2n. So I need to solve across from that 90 degrees first. All right, and I'm going to do 18 equals 2n. Divide by 2, divide by 2, n equals 9. All right, since I know what across from my 30 is, my 30 is n equals x. All right, I just found out that n equals 9. So now I'm going to say 9 equals x. I now know, whoops, I now know how to answer. This is 9. And I'm going to go ahead and solve across from my 60. Across from my 60, y equals n rad 3. I know that n is equal to 9, so y equals 9 rad 3. All right, and we're going to keep flipping. Okay, so right here it says, given the triangle below, solve for x and y. Write your answer as simplified radicals. Hope I have enough time to finish this. Okay, so again, I'm going to label my sides. This would be 30, so this is n, this is n rad 3, and this is 2n. The side that I know this time is n rad 3. So across from 60, 9 equals n rad 3. I'm going to divide by rad 3 and divide by rad 3. I'll have n equals 9 over rad 3. I need to multiply both the top and the bottom by rad 3 to get rid of that denominator. So what happens is I now have 9 rad 3 over 3. These divide, so this becomes 3 rad 3. So now I know n equals 3 rad 3. Well, if I'm looking across from my 30, my x equals my n. I just solved for my n, so I now know that x equals 3 rad 3. All right, and then across from my 90, y equals 2n. Y is going to equal 2 times 3 rad 3, which is simply going to be 6 rad 3. Okay, so there's that. And let's keep going. It says write the ratio for sine, cosine, and tangent for angle A. So we're working on this angle. We're going to put the googly eyes on this angle, and we're going to label our sides. We're just writing the ratio, right, guys? This is the one we don't want to overthink. Just writing the ratio. So this would be our opposite, this would be our adjacent, and this would be our hypotenuse. Remember, the acronym we use for sine is SO, the acronym we use for cosine is CA, and the acronym we use for tangent is TOA. All right, so for sine, it's going to be opposite over hypotenuse, which is going to be 12 over 37. And then for cosine, it's going to be CA, so adjacent over hypotenuse, 35 over 37. And for tangent, it's going to be opposite over adjacent, so 12 over 35. You're just writing the ratios. None of these can be reduced, so don't worry about reducing them. Okay, now we want to solve for x. All right, it's a right triangle, so that's great. But we don't know two sides. We only know one, and we know an angle measure. So we can't use Pythagorean Theorem. But because we know an angle measure and one side, we can use special right triangles, or trig ratios. So SOHCAHTOA. I'll label my sides. This is going to be my opposite, this is going to be my hypotenuse, and this would be my adjacent. Use what they give you. So since I have information on these two sides, this is what I'm going to use, which is an O and an H, which is sine. So I'm going to say sine of 37 equals 23 over x. I need to get x by itself, so I'm going to multiply both sides by x. And I'm going to have x times sine 37 equals 23. I need to get x by itself again, or still, so I'm going to divide by sine 37 and divide by sine 37. And I will get x equals 38.2. Okie doke. And then moving along. This time I don't know my angle. I do want to find it. I'm not trying to figure out this side. I'm trying to figure out this angle. I'm going to put my googly eyes here. This is going to be my opposite. This is going to be my adjacent and my hypotenuse. But remember, only use the sides that they actually give you information on, which would be the 29 and the 21, which would be an O and an A, which would fit the acronym for TOA, an O and an A. So I would say tangent x equals opposite 29 over my adjacent 21. Okay, I technically need to divide by tangent, but that's actually multiplying by inverse tangent. You're always going to use inverse tangent, sine, cosine, tangent, whenever you're trying to find an angle measure. So in my calculator, I would multiply those, and I would get x tangent -1 equals 29 times 21. I would do that in my calculator, and I would get 54.09. All right. We're almost done with this video. Sorry, it's definitely one of the longer ones. Okay, so again, we have a ladder, 10 feet. It's resting against the side of a house. Ooh, a really crooked house. The ladder is 7 feet away from the base. What angle does the ladder create with the ground? With the ground, so this is my x this time. I'm going to put my googly eyes on it, and I want to figure this out. This is my hypotenuse, right? It's across from my 90-degree angle. This is my adjacent. It's an A and an H that I'm using, which would be cosine, right? So I would say cosine x, that angle I want to find, equals my adjacent, 7, over my hypotenuse, 10. All right, remember, I do divide, but technically it's inverse cosine that I multiply both sides by. All right, so x would be equal to inverse cosine. And when you do that in your calculator, you would get 45.57 degrees. All right, moving along. This is going to be the law of sines. All right, so law of sines. What we want to do is we want to figure out what in the heck this angle is. All right, because we want to be able to set this up as a proportion. So I'm going to do 180 minus 99 minus 37, and I'm going to get 44. So I now know this angle is 44, and I can set up my proportion. I want to do that because remember, it's the angle and the side across from it is the proportion. So since I'm trying to find this side, I need to find that angle. I'm going to do sine 44 over x equals sine 37 over 17. I'll cross multiply. 17 times sine 44 equals x times sine 37. I'll divide by sine 37, divide by sine 37, and I will get x equals 17 times sine 44 over sine 37. When you plug that into your calculator, you'll get 19.62. Okay, and remind me, we need to go over law of sines and cosines, just in case you're forgetting the formulas. But this video is so long, so we're going to wait on that. Now we're going to do law of cosines. So it's going to be x squared, all right, always that side that you're trying to find, equals the two sides that you know, 29 squared plus 21 squared, minus 2, that's 2 is simply part of the equation, times those sides again, times the cosine of that angle across from the side you're trying to find. Okay, so we're going to have x squared equals 841 plus 441 minus 1,218 times cosine 113. All right, that simplifies down to x squared equals 1282 plus, when we multiply those, we end up with a positive 475.91, and then you will take the square root. Oh, whoops, that's going to be x squared equals 1757.91. That's a 4. Then you'll take the square root, and you will get 41.93. And that is it for this section.